welcome to my channel. Today we are going to learn about how we are going to see that when we are appending say 100 million of integers to an array, how much memory does it consumes, right? And how much other CPU allocations are being there, right? So to do that, first let me create a list which is a slice of integer, right? And let me print the length of the list. So ideally it should be 0 because it is an empty slice, right? So let me run it. Yes, it is 0. Now to get the memory thing right, we need to know about a package called runtime package. Now here we have this package memstat struct, right? So I'm interested in this three majorly. One is alloc, which is an unsigned integer 64 total allocation and the systems, right, in this struct. So these are three parameters I'm looking into where I can have a fair idea of how much heap objects I'm collecting and the cumulative and the system memory bytes is there, right? Great. So to do that, right, let me first understand what we need to do here in this thing. So first we need to create a struct, so let me create a struct which can get those values here. So let me create a struct called memory stats, right? And this is a struct type, and then I need these three parameters. One is allocated, and that would be a string type. One would be total allocated, that would be a string type. And what was that other? That was a sys, right? So I will be giving a system of string type. Great. Now this is the memory struct, or I can give it a stats that will connect this thing. Okay, great. Now what I need here is I need a function who can calculate this, right? Let me get a function called getMemory, right? And it returns this memory stats struct type. So I will be having these three fields. So in this memory struct type, right, I want to import this package called runtime, right? So let me give a memory, so let m and then runtime dot memstats, because I'm more interested in this memstats thing, right? So yeah, runtime dot memstats, and then I'm going to use this runtime read memstats, right, which will be asking for a pointer, and I have this m value, so I can use this m value, right? So here you can see the read memstats populates m with memory allocated statistics, so it actually returns me all those things. So if we go here and if we search for read memstats, you can see here this is looking for a pointer of memstats as a pointer, and it populates m with the memory allocated statistics, right? And it also helps in this heap profile and the snapshots, garbage collection and all that, right? So this is all we need for. Great. So now what I did is I just assign a variable m for which can get those runtime memstats as a pointer and then use that into here. Great. Now what I'm going to return here is, because this expects a struct, right? So let me return memory stats. Okay. Now allocated field is there. So in here I will be saying fmt.sprintf. Okay. Now sprintf is a function, it takes any structure and it returns always a string. Since here allocated, it expects a string, right? So I need to return a string type. So this is a memory of memstats type, right? So I need to, whatever the value is there, if it's an int, since percentage they are using, so int should be converted to a string, right? And let me give a memory mib, and then I'm going to use this m. So okay, first is the allocation. So my goal here is allocation. Now this comes in bytes, so I will be converting to MBs, right? Then I'm looking for total allocated. I will be doing the same thing. I will be using %d mib, and then m dot total allocation which will be again in bytes, so it should be divided by 1024 and again to make it MB. And I'm looking for system, so it would be %d for integers, and then I will be using MIB and then m dot sys, right? And whatever the value is, I should be dividing by 1024 to get it in the memory as an MB. Great. So now I have this function ready, so whose work is simple. Whatever the memory stats we have allocated, like allocate total allocated system, it will return to me. Now my goal here is to first check it out that what is the memory usage is coming. So let me just give a printf statement. Okay, memory usage. So now since there's 0 elements into the slice, right, so it will be no memory usage, right? So I should not be having any memory usage there. So plus v for this struct, okay, and I will be using get memory. So this function is now coming. Now I will be appending this thing, whatever the variable I have assigned, right? I need to assign a variable also. Okay, hold on, I need to assign one variable. I have not assigned one variable, so let me assign a variable with the list length, right, as a name, and it is of integer type, and I would be saying, say, 1 exponential 1, which means 10. Okay, that's the exponential thing. Great. So for I equals to 0, I less than list length, and I plus plus. Okay, and what I would be coming here up with, I would be appending this list with the I, right? So that means that list will be there. Let me just print out and show you. For this is a very small number, so I can show you. When I will be putting the 100 million numbers, I will not be showing that. So let me print the list for now, and I want to get few things. So I will be copying these for the length of the list, and then what is the memory being consumed. So this is for only 1 to 10 integers. Okay, 1 exponential 1, right? So let me just see how it happens. So you can see here, this is memory allocation is 0 in the initial time, system memory is 8 MB, and they are all happy. And this is what I am trying to say, when we are going to append a single integer to the list actually. So the final list will be like this: first element is 0, then 1, then 2, 3, 4, and so on, and it will take up till 9, because we have given 1 exponential 1, right? That is up till 10 integers. Now the things comes here interesting when I would be saying 100 million, which is like simple 1e9, there is 1 exponential 9, that is after 1 there are 9 zeros, right? Now this figure will be changing, so there will be so much printouts if we want to make this list. So I don't want to print out this list, right? What I will be doing is I will just see what is the memory being consumed, right? Right, let me just hit this thing. So yes, initial length was 0, and the memory usage for here, you can see this thing, it was okay. Let me just come here also. So initial it was no much memory, all happy. Now when I just made 1 exponential 9, right, you can see here it has allocated 8153 MB, which is roughly around 8 GB, and total allocated is around 40,766 MIB, right? System is having 1753. It's a very short video about appending the integers and understanding what is the memory being consumed while you're doing that operation, right? I hope this video is informative. Thank you for watching.